So we'll see the next concept, capacity of the tank. So far we saw what is time taken by all the pipes to fill the tank when opened together, or time taken by the pipes to empty the tank when opened together, or for single pipe time taken to fill the tank. So all this type of questions we saw. So sometimes they ask questions based on the capacity also. So capacity of the tank will be asked, the filling time of these pipes will be given. And now how to work this capacity of the tank? So we can follow the same LCM method for more than 2 taps, or if you have 2 taps you can use that product and sum method. And for better understanding, now we'll jump into the examples and we'll see the example. So we'll see an example now for the clear understanding of this capacity of the tank, how to find the capacity of the tank. So here the question is, pipe A and B can fill a tank in 30 minutes and 20 minutes respectively. Another pipe C can empty 5 liters per minute. So when all the 3 are opened together, so they can fill the tank in 15 minutes. So find the capacity of the tank. So in this question, we have 3 pipes, A, B and C. So filling capacity for A and B is given. So A fills the tank in 30 minutes, B fills the tank in 20 minutes. And for C, it is an emptying pipe. So but capacity of emptying is not given. So but it is given that how much liters it can empty per minute. But total time is given. So with this total time, we can find what is efficiency of C. That is, in what time it can empty the whole tank. Say for example, if it is 10 minutes, so if it is emptying the whole tank in 10 minutes, and now multiply it with liters it is emptying per minute, we can get the capacity. So now as total time is given, so we can find the efficiency of C. And now from there, how to find the capacity of the tank. So we'll see the working. So in this question, capacity of the tank is asked. So though the capacity is asked, we have more than 2 pipes, so we can follow the same LCM method. So we have 3 pipes, A, B and C. So in how many minutes pipe A can fill the tank? So it can fill a tank in 30 minutes. And now pipe B, how many minutes it can fill the same tank? So it can fill the same tank in 20 minutes. In how many minutes C empties the tank? So but that is not given. So that is what we have to find now. So we'll take as a question mark here. So by time, but time taken by all the 3 pipes is given to fill the tank. So in how many minutes all the 3 pipes open fills the tank? So it is in 15 minutes. So now we'll find LCM for time taken by all these pipes. So take LCM for 30, 20 and 15. So always time taken together will be a factor of these 2 numbers. So it is enough if you find LCM for this 30 and 20. So it will be including this 15 also. So find LCM for 30 and 20. So LCM is 60. So though we consider LCM for 30, 20, so 15 also will be a factor of that. So it is enough if you find LCM for time taken by A and B. For 13 and 20 it is 60 liters. So 15 is a factor of this 60. The assumed capacity is 60 liters. So now we'll follow the same working, that is work done by A, B and all the 3 pipes. So if the capacity is 60 liters and if A can fill it in 30 minutes, in 1 minute how much water A can pour? So A can pour 2 liters and B in 1 minute it can pour 3 liters. And how many liters C can pour cannot be found because efficiency of C is not given. So with this data we can find the efficiency of C. Now all the 3 pipes fill the tank in 15 minutes. So in 1 minute how much water all the pipes would have poured? divide 60 by 15, it is 4 liters. So A has poured 2 liters per minute, B has poured 3 liters per minute. So what is the amount of water by A and B? So that is 5 liters. But how much water we have after 1 minute when all the 3 pipes are open? So we have only 4 liters. So A and B has poured 5 liters. Effectively we have only 4 liters. It means that how many liters C has emptied? So 5 minus 4, C has emptied 1 liter. So if C can empty only 1 liter per minute, so in how many minutes it can empty 60 liters tank? So it is 60 minutes. So in 1 minute it can empty 1 liter. So to empty 60 liters, C needs 60 minutes. So now we have got efficiency of this pipe C. So pipe C can empty the same tank in 60 minutes. We are asked to find capacity of the tank. Now what is the data given? So how many liters C can empty per minute? So it can empty 5 liters per minute. So in 1 minute, if C can empty 5 liters, in 60 minutes, how many liters it would have emptied? 60 into 5, 300. So capacity of the tank is 300 liters. So mostly when they give this question, so first taking this data, so most of them confuse the workings. So don't touch this data. So this is to find capacity only. So C can empty 5 liters per minute. So this is used to find capacity of the tank. So with the detail given, we can find the efficiency of C. So using the same LCM method, we have found efficiency of C as 60. So C can empty the full tank in 60 minutes. So per minute, if it can empty 5 liters, capacity of the tank is 60 into 5, 300 liters. So please note that the actual capacity of the tank is 300 liters, which is the answer of the question. So this 60 liters, we have assumed it as the capacity. So this is the assumed capacity. So we have assumed this capacity to make our working easier, and this capacity was assumed to find efficiency of C. So based on this assumption and all this data, we have found efficiency of C, and this is assumed capacity, and actual capacity is, so with the data which they have given, so it can empty 5 liters per minute. So finding efficiency of C, we have found the actual capacity of the tank, that is 60 into 5, 300 liters. So please don't confuse with this. The actual capacity is 300 liters, and this assumed capacity is for easy working, and this is used for finding efficiency of C. So don't confuse between the assumed capacity and the actual capacity. So we'll see the next example. So the question is, rate of flow of water in pipes A, B and C is 22 liters per hour, 36 liters per hour and 28 liters per hour respectively. So when A and B fill the tank, C empties the tank. When all the three are open, the tank is filled in 15 hours. Find the capacity of the tank. So in this question also capacity of the tank is asked. So seeing this question, many think that it is very tedious and they get panic while working. So but here work itself is given. So actually one set of base working which we do to find work done by all the 3 pipes or 2 pipes is already given here. So though it seems to be very difficult and tedious, it is very easy to work. So we'll see the working. So in this question, there are 3 pipes A, B and C. Rate of flow of water itself is given. So normally time will be given and we'll take an assumed LCM as the assumed capacity, and we'll find what is work done by A, B and C. So in this question, though this seems to be very difficult, So here work itself is given, so which is very simple to work out. So within seconds you can get the answer. So we have 3 pipes A, B and C. So normally time will be there. So A fills in 10 minutes, B fills in 15 and 12. So we will find LCM for assumed capacity and we'll convert all the time to work done and we'll proceed. So here work done itself is given. So how much water A can pour in 1 hour? It is 22 liters. So rate of flow of all these pipes is given. So A 22 liters per hour, B it is 36 liters per hour. And what is rate of flow of water in C? It is 28 liters per hour. So normally we will find only this work. So that set of work is reduced for us. So already they have given the data itself. So work itself is given. So rate of flow of water for A, B, C is 22, 36 and 28. So but A and B are filling the tank. C empties the tank. So for filling we'll add, and as C is emptying, we subtract. So now how much water is poured by all these 3 pipes in the tank? So this is so much liters per hour. B pours 36 liters per hour and C minus 28. So by solving this we get 30 liters. So all the 3 effectively pour how many liters of water? 30 liters of water. So now it is given that all the 3 pipes when opened, in how many hours they fill the tank? In 15 hours they fill the tank. So in 1 hour they pour 30 liters. In 15 hours how many liters would have been poured by all these 3? So just by multiplying you get the answer. So though this seems to be difficult, so it is not difficult at all. So they have given the work itself. So 30 liters per hour. So after adding and subtracting, as work is given, just add and subtract. You get effective water poured by all the 3 pipes into the tank. So 30 liters. And in how many hours they fill? They can fill the tank in 15 hours. So what will be the capacity of the tank? So number of liters into hours, it is 450 liters. The capacity of the tank is 450 liters. So just use the data. They have already worked and gave you the work itself. So work done by A, B and C is given. As C is emptying, adding and subtracting, we can get the amount of water poured by all the 3 taps in 1 hour. So in 1 hour 30 liters. In 15 hours 30 into 15, 450 liters is the capacity of the tank. So no need to use LCM and all. So already they have given the work itself. So don't get panic when you see this type of question. So within seconds you can work out the answer when you understand the concept. So understand the question and proceed. Working will be very easy. So we'll see the next example. So we'll see the next question. So the question is, a boy and girl together fill a cistern with water. The boy pours 4 liters of water every 3 minutes and the girl pours 3 liters every 4 minutes. How much time will it take to fill 100 liters of water in the cistern? So this question was asked in SSC CGL Tier 1 2008. So in this question, so you have 2 different timings and 2 different capacities. So we'll see how to work out this question. So in this also time is asked. So we are dealing with the capacity. So instead of capacity they are asking time taken to fill 100 liters of water. So there are 2 types of efficiencies, that is a boy and a girl. So how many liters this boy pours? He pours 4 liters of water. In how many minutes? So in 3 minutes. And now what is the amount of water poured by the girl? She pours 3 liters. In how many minutes? 4 minutes. So the boy pours 4 liters in 3 minutes and the girl pours 3 liters in 4 minutes. So as usual, so we will find LCM for this time taken. So for 3 and 4, what will be the LCM? 12. So here we are forming a common time for both boy and the girl. So we have different timing. So in 3 minutes 4 liters, in 4 minutes 3 liters. So we will take LCM for 3 and 4. So it is 12 minutes. So now how we can get 12 from 3? Multiplying it with 4, we get 12. And the same 4 you multiply with this work done also. And from 4 how you can get 3 into 3. And the same 3 you multiply with the work done by the girl also. So now what is the data we have? The boy pours 16 liters in 12 minutes. And the girl pours how many liters? 9 liters in 12 minutes. Here work itself is given. So common time we have, so we can add this. So in 12 minutes, so instead of finding for 1 minute, it all takes tedious working, complicated working. So just find LCM for time taken and have a common time for both boy and the girl. So here 12 minutes will be common and it will be easier also to work out. So in 12 minutes, so what is the amount poured by boy and the girl? So boy pours 16 liters of water. So 16 liters. And how much water the girl pours in 12 minutes? 9 liters. So now this boy and the girl in 12 minutes, how much water they have poured? 16 plus 9, 25 liters. Now instead of taking this for 1 minute and working out, what is the question given? So it is asked what will be time taken by this boy and girl working together to fill 100 liters of water in the cistern. So for 25 minutes they take 12 minutes. So what is time taken to fill to pour 25 liters? 12 minutes. Now how much water is needed? 100 liters. So we can get 100 from 25 itself. So multiply 25 with 4, we get 100 liters. So multiply the 4 on the other side also. So in how many minutes? 12 into 4, 48 minutes is the answer. So for this answer is 48 minutes. Answer is option C. So in this question, so though this seems to be complicated, we can take a common timing and what is work done by boy and the girl in this common time. So boy and girl can pour 25 liters of water in 12 minutes and we need 100 liters. So just by making this 25 as 100, that is multiplying with 4 on either side. So 25 into 4, 100 liters is poured in 48 minutes. The working is very simple. So we'll see the next concept.